Hello friends, this video on acid and base part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Now let's study what is base. Base is something which has excess of OH minus ion, and it's the old definition which is still used by NCERT, CBSE. But this is the old definition. The new definition says that substance that accepts H plus ion is called base. This is a new definition actually, but I think our book still follows the definition, so you can take any of this because in 99% of this case, this definition is true, but there are certain scenarios which are base but they don't have OH minus ion, right? So we'll take that. And it has bitter taste and soapy in touch. So base will have bitter taste, the taste is bitter, and they are soapy in touch, right? And one example was HCl plus NaOH gives NaCl plus H2O. So in this, if you see, this guy has OH minus ion, so this with this definition is true. Also, if you see that OH minus ion will accept this H plus, this becomes H2O. So both definitions are true in this case. So in 99% of the reaction, both the definition is true. Right, so we'll take an example where it has the first definition fails. In that example will be reaction of ammonia with something. I'll explain this. So before that, let me take this alkali part. What is alkali? Alkali is a subset of base, right, which are water soluble. So you can say water soluble base are called alkali because all the base are not water soluble. Some base are water soluble, some base are non-water soluble. So water soluble base are called alkali. For example, sodium hydroxide, potassium hydroxide, they are all water soluble. Correct. So it is like this. You have this base, bigger set in terms of mass, and then you have alkali. Alkali is a base which is water soluble. Correct. So example of base which doesn't dissolve water is called ammonia, NH3. So if you see, this guy is not an alkali but it is a base. Right? For example, in this case, my ammonia will be somewhere here. Correct. Also, if you see, I told you this reaction, right? Here, if you see, NH3 is a base, HCl is an acid. The reaction is NH4Cl. Here, if you see, it doesn't have OH minus ion at all, right? There is no OH minus ion. Still, it is a base. So, with old definition, this is not. We will not able to justify this equation, but the new definition that accepts H plus ion, we can justify this equation and we can say ammonia is a base because this guy, if you see, ammonia will take one hydrogen ion from this. Too big NH. So if you see, we have two definitions of base. The old definition was excess of OH minus ion, and the new definition is something that accepts H plus ion. And we have something called alkali. Alkali are nothing but water soluble base. There is a subset of base. All the alkali are base, but all the base are not alkali. Hope you understand this. Example, ammonia is a base but not alkali. And if you see a sodium hydroxide, that is a base and alkali both. So in this case, if you see, NH3 has taken one H plus ion. Correct. The next question is, why should we study base? As we have done a little bit of application of acid in real life, similarly we do application of base in real life. So here you see the food also has, some of the food has basic thing. Some of the medicines are basic in nature, for example antacids, which are used to remove gas. They are all basic in nature. Water, as I told, is all both acid and basic. We'll discuss that part. So water is also basic. If you see our body, right? So when you get this gas and all, right? So this thing burns and you feel that burning sensation. You take the medicines to remove the acidic thing in your body. So there we use some base medicine, right? You need some base to cool this down, cool down this guy. Base is also used to make the glass articles, the glass things, the glass jugs, mug, glass utensils, everything is manufactured using base. The chemicals dye, this is dye, the dye needs base. The toothpaste is basic actually. And how it works, it will explain that with germs and all, it increases the acidic nature of our teeth, and with that the teeth start corroding, and to prevent that we use toothpaste, because toothpaste is basic in nature, and it makes the whole teeth more basic. It nullifies the acidic thing. So I will explain, we'll learn this part. So the toothpaste is basic thing, and the fire extinguisher we use is also basic. The deodorant, this is the deodorant is also basic. You see, the perfume was acidic, and that's why we never used to apply perfume directly on a body. The deodorant is basic, it doesn't harm the body that much, so we can apply the deodorant directly to a body part. So these are some of the application of base in a real life. So hope you understand the application, the food, the medicines, the water, the fire extinguisher, the toothpaste, the deodorant, dye, glass, medicines, all the places we use base in our life. So the common base we have is aluminum hydroxide. It's called antacids, and deodorant in both cases used. Ammonium hydroxide used for glass cleaner. Calcium hydroxide is caustic lime, plaster. Magnesium hydroxide is called antacids also, laxatives also. Sodium bicarbonate is also called baking soda. Sodium carbonate is used for detergent. Sodium hydroxide is used for drain cleaner. Sodium hypochlorite is nothing but bleach. So these are the common base which you use in our daily life. Please remember these. So I will take it once again. Aluminum hydroxides, AlOH3. Ammonium hydroxide, NH4OH. Calcium hydroxide, CaOH2. Magnesium hydroxide, MgOH2. Sodium bicarbonate or sodium hydrogen carbonate, both are same. NaSCO3 called baking soda. Sodium carbonate, Na2CO3. Sodium hydroxide, NaOH. Sodium hypochlorite, NaClO. These are the common base which we use in our day-to-day. So based on strength, we have strong base and weak base. Similar to this, the acid definition: strong base which completely dissociate into ions in aqueous solution, weak base which do not completely dissociate, right, in ions. Example of strong base: sodium hydroxide, potassium hydroxide. Example of weak base is ammonium hydroxide. Correct. Based on concentration, we have dilute and concentrated base. Similar example, we have low concentration of alkali, because it has to be alkali if you are talking about aqueous solution, because if it is not soluble, then you don't have aqueous solution. So the low concentration of alkali, that means it is a aqueous solution in this dilute, and high concentration means it is a concentrated. So here also concentrated is more powerful and dilute is less powerful, similar to the acidic definition. Based on state also, we have solid base, liquid base, and gas base. Solid is sodium hydroxide, liquid is water, and gas is ammonia. So we can have base in all these. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.